Yep. Hello, everyone, and welcome to the meeting. Hope your summer's going well. And today we were going to cover a little bit about Brainiac as well as the brain hack that's going to be coming in July. So I'll just hop right into the main topic for today of Brainiac. I expressed interest in this last month, but we didn't cover it because I was either prepping to go to a conference or away at a conference. I was prepping. I wasn't at the conference yet. But I was able to meet one of the developers of Brainiac when I was at OHBM, Sam, really great guy. And I actually didn't talk a lot about Brainiac, but I was able to connect the dots, and I have looked at this tool since, and it's looked like it's gone under a lot of revisions in recent history. It's a collaboration between Princeton and Intel is the general funding architecture for this project, and from what I've seen, it looks like it can do some pretty interesting analyses. I haven't actually stepped beyond the tutorial side of things, but it looks like it could be really useful for getting, once your data is already post-processed and you've gotten the values that you want to analyze, this will help on the analysis side of things. With that said, they do offer they do offer some tutorials on even like reading in your data and dealing with that. So you kind of not necessarily handholds, but it provides you a lot of boilerplate code in order for you to implement and apply the methods to your own data.
So is this like at the point you have a measurement, so you have a big CSV spreadsheet type analysis of your data, or is it before that?
It will be it. It could be a CSV, or it could be you could have it loaded in. Well, yeah, it'll probably be a CSV, but you can load it in Python and then like skip. Like for the example that I'll be covering today, they have ROIs listed as the voxels are on one axis and then trials are on another axis. So it is formatted probably to be in some lower dimensional form, or at least it's assumed that you know how to, if you want to load in the nifties itself, they offer some boilerplate and it's a little bit assumed that you'll be able to decompose the data into like a format that is readable by some of these analyses. That said, I haven't gone through all of these tutorials. In fact, really the only one that I've been through is the representational similarity analysis. So really take everything I say with a grain of salt. And for running through these tutorials, they offer different options. The one that I'm going to show today is the one that's completely in the browser. So from Google Collaboratory, which is, as far as I can tell, like Jupyter notebooks being hosted through Google. As far as I've tested, it comes with most of the features that you'd like from Jupyter notebooks for creating new cells, code cells, markdown cells, and being able to do some textual formatting that's maybe a little bit different than what it would look like in a Jupyter notebook, but pretty much the same. The only thing one of the things that I couldn't do, or at least on my first pass try, was getting all the help information from a code block. So oftentimes you can hit Shift Tab inside a Jupyter notebook whenever, well, let me just pull it up. Not that one. So oftentimes you can, where is a function? maybe right here. Oftentimes you can hit, oh, that didn't do what I wanted. If there is a function right here. So oftentimes you can hit Shift Tab on a Jupyter notebook inside the, or maybe I can zoom in here a little bit. See if the zoom helps. So oftentimes you can hit Shift Tab inside a function here, and you'll get like help information or some type of information that will tell you like what are the arguments that the function takes and all the helpful information for actually writing out code. That was something that I could not replicate here, but with that said, I think it's still a cool thing that you can just run completely in your browser, which is super awesome. And as I said, I haven't really dug into everything, so I could be missing something that could allow you to look at that information. But for Brainiac, they walk you through the steps here, and I just literally walk through the steps and follow the directions exactly, and they work perfectly for me. So I was able to go to Colab research.google, and I was able to open their tutorial setup book, which essentially installs Brainiac as well as some of the other packages to run the tutorials, and you can download the data for running particular tutorials. So I just downloaded the data for the RSA analysis, but you could download the data for all the different tutorials if you want. Some of them are a little bit longer than others. Like this data set might take a little bit to download and unzip, but a lot of the other data sets don't take too long. So you can just download exactly what you need for whatever tutorial that you want to run. And what I wanted to cover from one of their analysis tutorials was the representational similarity analysis. This is something that I've been tangentially exposed to at multiple points now, since it's very related to my work with generating beta series, where the main idea is just we want to get a measure of activation or something per trial, and we want to maybe look at those activations for a particular voxel or all the voxels within a particular ROI across all trials. And maybe additionally, those trials fit into different categories such as they say colors or shapes. So maybe I want to group the trials into colors and shapes, and then I'll be able to see how similar are all the trials, or how similar are all the voxels in their activation patterns for colors versus shapes. So at least right now, as my understanding goes, this representational similarity analysis, or RSA, seems relatively straightforward and something that I could definitely apply it to a lot of my own data, and provides a nice lens into, I guess, the natural kind of groupings of data in within fMRI. RSA is also applicable for other methods of analysis besides fMRI. I think it was actually first started out with neural coding for single unit or multi-unit recordings of actual neurons. So it's kind of been a borrowed thing from or borrowed from these single multi-unit recordings to the fMRI literature space. All right, so do people have questions about Brainiac right now, or like what you might use it for? Does it seem like it's pretty well defined as like a, as I talked with Marco earlier, like as a post-analysis tool? Like you already kind of have your data set up. Yeah. Okay. They also give, within the tutorial, I mean, anyone can walk through these, so I'll give my little synopsis without trying to repeat what has already been said. They walk through exactly what we're going to be doing. In this case, we are looking at a data set in which there are 96 visual stimuli from 6 different categories. And we're essentially going to be looking at the brain responses in different regions of interest for, artificial inanimate objects, human body parts, human faces, natural inanimate objects, non-human body parts, and a non-human face. So this is where, as is common for any notebook, is to import all the packages that you'll need and set up MATLAB inline so that all your figures show up within the notebook. And it looks like they even did some accessibility setting where you can, for Seaborn, they have a palette for colorblind people, so it should be, all the colors should be distinguishable if you're colorblind. And since I'm partially colorblind, it passed my test. I was able to differentiate the colors. And they also have some utility functions just for, I guess, reducing the amount of boilerplate that would be in the tutorial otherwise.
Can you use R instead of MATLAB in this case?
For plotting? There is... I mean, Matplotlib is just the re-implementation of MATLAB's graphical software in Python. So the R equivalent, there's also been a re-implementation of R's programmatic graphical engine in Python. And that is called Plot9, I believe. So if I just look that up right quick. Plot9 Python. So Plot9 would be the Python equivalent to trying to copy R's ggplot. Yeah.
Okay. Cool.
Yeah.
So that does exist. Yeah, good question. But here we're using Matplotlib, and Matplotlib is, at least for now, the most popular graphical engine, and things that are built on top of Matplotlib, like Seaborn, are popular graphical tools in Python.
Because it's superior?
Is it?
Is that why it's popular?
Because it's superior?
Or just more
I don't know.
accessible?
I would say Matplotlib has a richer history than Plot9 does right now. Matplotlib got started, I want to say, like in the early 2000s. I want to say Plot9 is much younger than that. So what Matplotlib has as an advantage is a lot of history in its development, and yeah, just like staying power. But I have heard of people asking about Plot9, and they've had success with it. Okay, so it'll have you load in the data for a particular subject, and in this case, this could provide, if we look into what code they actually put in for load data for a subject, the subject file is actually a MATLAB file. So if we dig into that function, it'll probably give you some hints on how to load MATLAB files into Python as well. So again, what I found from looking at these tutorials is just a lot of little nuggets of knowledge that allow you to be more proficient in whatever that you're trying to do. And then they also insert little exercises where they want you to keep the tutorials interactive. So for here, I've done some of the exercises just based on what I thought that they wanted. So here they say to print the name of each category. So for category and categories, print the category. And then report the shape for each ROI and what each dimension means. So we can see in the dimensions for number of rows, it's always 96, which represents the 96 trials. And here, I guess I would call it the column dimension represents the number of voxels. So for each ROI, they have a different number of voxels.
The ROI is 96. Can you say that again? I'm sorry.
So for each ROI, they've essentially, I guess I would say, vectorized the voxels so that they are in a single dimension instead of having the three-dimensional structure.
Okay.
So if it was like a 9 by or a 3 by 3 by 3 square, now it's just 27 voxels that are lined up in a single line,
okay,
instead of 3 by 3 by 3 in those dimensions. Okay. And the next, they label, give some hints on how to work with Matplotlib, and provide some nice intuitions about what is, say, like the variable labels. Let's just look and see what that is, just so we have an intuition of what is it actually plotting across the x-axis. So if we look at labels here, Shift-Enter still works. We see the numbers, they correspond to 1, 5, 2, just floating point integers. So in order to tell what those numbers actually represent, they also have another variable labeled dict, which gives a dictionary that lets you know that whenever you see the number 1, it corresponds to artificial inanimate objects. If you see 2, human body parts, so on and so forth. All right. So now we can see how they plotted those labels using across the x-axis and labeling the x and y-axis with their appropriate marks. And what we can see is that as we go across the x-axis, the categories are not in a block pattern, so it's just I think in this case they're just trying to demonstrate that this is more of an event-related design where everything is kind of mixed up together. So we can continue running things. They have select your ROI ID. So 1 would be the right FFA. And we can run this, and it shows basically the core computation that's going on here is that we're taking the ROI data from the ROI ID, and let's take a look and see what is actually in that data. Oop, didn't want to do that. There might be a way to like automatically insert code tells. Oh, that ended at the end. Okay. That's fine. And this will return a two-dimensional NumPy matrix, again, that has the shape of 96 trials by 70 voxels. So if I scroll back up here, basically what we're doing, further up, I don't know why it put me all the way at the bottom. Okay, we're almost there. Okay, so basically what this core coef function is doing is that it's taking each column of the, or what is it? Yeah, it's taking each column of the matrix, which each column is a voxel, and it's correlating that voxel's essentially trial series with another voxel's trial series. So for say for trial, at least I think I said that right. So
What do you
then,
mean by trial series? Is that average?
I guess like it's for, so we have, so it's per column, yes. So we have a value for a particular voxel at each trial for like how much was this voxel activated for trial 5, say. And for, then we want to see how average is that, right?
Is this what you
Okay.
were talking about for that paper that we saw on Monday?
For
The Matt's paper?
Yeah.
With this same thing that you wrote down what it actually meant?
Yeah, this
How
is
they
similar to
do
that. Yep. Yeah, that was exactly for our journal club paper that was on last Monday.
Voxel by trial matrix per region per ROI.
Mm.
And correlations between all the columns, which are trials.
Mm-hmm. So then we have a voxel in which we have, or then we have a cell in this matrix. Now let's see if I can say this correctly. So I guess like this is how much trial 0 correlates with trial 0 for this ROI, which would be 1 exactly. And then this is how much trial 0 correlates with trial 1. So yeah. Okay, yeah. So across, yeah, okay. So yeah, so across all the voxels, how similar is trial 1 to trial 0?
Okay, and then would you group by trial type, or would you have it, or would you?
And then we will group by trial type, exactly. So that would be the next step. Sorry, I don't know why it took me so long to remember that, but yes, it is.
Or would
Yeah.
you ask the algorithm to spit that back out, and then hope that your trial type would look the same? That would be something different.
I'll continue talking, but I'll assume that maybe will help answer your question.
What is trial type though in this case?
Trial type is either the human body part, the human,
Oh, right.
yeah, all of that information.
Standard type.
Okay, those categories. Okay.
Mm-hmm. Then they had just a regular Pearson's R. Then here's a Spearman's correlation, just for letting you know that you can do correlations in different ways. So with this one, it's exactly what we were talking about. We want to group the trials by their actual trial type. So trial, so with what we did using argsort and using those sort IDs to reorganize the NumPy array, we were able to put all of the trials in category 1 first, then category 2, then category 3, then category 4, 5, and 6, which again correspond to those human body part and artificial inanimate.
Like that in the graph.
Why are they linked? That's just how Matplotlib defaults, and it's probably
those points don't represent data.
Yeah, this is interpolation between the steps.
Oh, okay.
So this is a data point, and then that's a data point.
Okay.
And then this is all just like, yeah. Yeah, I don't know how you do it in Matplotlib off the top of my head. So it was probably, what's up?
There's a step, what are they called? Step function plots.
Okay. Yeah.
Do you know what I mean by that? Like from probability, where you have like those disconnected bars.
Yeah. So yeah, it might be possible to do that. But yeah, that's good. It is.
Anything stepwise.
Yeah.
It would be how you would plot it. Yeah.
Yeah. Because yeah, I guess the ideal is that these connection points would not exist.
Yeah.
Change your ROI
They don't
here.
mean, that's why I was just making clarifying.
Yeah.
Like they don't mean anything.
Yeah, they don't mean anything. So now, with those being sorted,
Does bar length correspond to number?
of objects?
Yes, yeah. So we can see that there's a plethora of category 1 and looks like category 4 have the most of the same
Were there
trial
6
type.
categories?
Yes. I keep forgetting what they all are, but there are 6 of them, and so artificial inanimate, human body part, human face, natural inanimate, non-human body part, non-human face. 3, 3, 6. So now in the next one, they do present them in an order that exists.
Okay.
Okay. So now we have artificial inanimate, and then it's these darker lines that help break into the different categories.
Right.
Then human body part, human face, natural inanimate.
Before again? Sorry.
What's up?
Before this matrix, what was?
What was the order? It was in the order of which the trials were presented.
Yeah.
So not grouped by category, just by, if trial 1 was a human face, then trial 2 could have been a human body part, and then trial 3 could have been something else, so on and so forth. So this one, they took all the trials. So this one could be literally from like the order in which the participants saw them. This could be trial 3, trial 7, trial 11, just all matched together to be within the same category. Exactly. And then he talks about digitizing things, and I guess right now, to me, it feels like a little bit more of a detail than a core concept. I think they're doing this to replicate what actually happened in the crash code. So yeah, so that the thing would look similar. But digitizing, I mean, it doesn't seem too difficult conceptually, but I just don't want to cover it right now. The next step that they wanted to do was to order it in a way that means. Did you have a question?
Oh no, I was gonna ask, but I'm waiting for you to say.
Okay.
I mean, I was gonna ask about that.
About okay.
About what you're explaining right now.
Okay. So they're now grouping the trials into a more, I guess, natural ordering of groups. Okay. So what they say
for the same ROI?
For the same ROI that we're doing right now, but we could switch out which ROI we look at, and it would be
Is there,
like, for a particular structure, what are the ROIs again?
The ROIs are the
right, left, FFA, and
the right, left, FFA, and then there's 2 more. Fusiform.
Fusiform face area.
Yeah, the fusiform face area. That's what we got. Yeah, exactly. There we go.
Compare the patterns between ROIs?
So this notebook, or at least didn't get quite that far, but you can imagine one of the things that you could do is simply take a summary measure of like how correlated are the trials that are within a group, and then compare how correlated are those trials between the within versus outside the group. So then you could get like an actual like unitary summary measure of saying that this structure for this particular for these particular trials, say human face, are more correlated with each other than how they look when they are when you're looking at the trials that are, say, non-human face. So, I mean, it's kind of just putting a name or like a quantitative value to what we'll see visually here in a moment. So what they had us do here is that we kind of move from most human-y processing to least human-y like as a natural ordering. And then this is where we had to write in our own code. So I came up with this. This is I feel like there's got to be a better way, but this is the strategy that I came up with in order to order the labels for the trials to make them so that they.
So label dict stim 0 is column.
So this is but this is returning.
0 is row.
This is returning a tuple. This npwhere command. And labels is just a one-dimensional numpy array.
Okay.
So this will return the indices in which, and then label dict for stem, this returns an integer based on where what number corresponds to human face, say. So like labels are 1 through 6. What I have here are strings, and what connects the strings to the numbers is this label dict, or this dictionary. So label dict human face, I forget which one it is. It might be 3. So human face is 3. So when I say label dict human face, that will return the number 3. So I'm looking where the labels, which is a numpy array, where is it equal to 3? And then that returns a tuple, which is similar to a list, but basically you just want to.
Your tuple is like some kind of string and then like an integer, right? Or it can be a string and an integer.
Yeah, tuples can be a collection of like any particular object. So I just want to, in this case,
A what?
a tuple, tuple.
So it's TUPPLE?
No, just one p.
Yeah.
But
I used the tuple.
tuple.
With E at
I
the
don't know.
end?
Yeah, it's TUPPEL. Tuple.
Tuple. I'll insert another code cell here
It's such a-
so we can take a look. So this should work, I think. Yeah. So labels, one-dimensional numpy array, label dict, which I can insert another cell just so we can look at that again. Label dict just ties strings to numbers here. So when we do label dict human face, it's just going to return the number.
Nice.
So I'm basically asking here what indices do our labels equal, which is again a one-dimensional numpy array. When is it equal to 3 per se? And then this returns all the indices in which labels, and we'll just take a quick look at labels here. When is labels equal to 3 per se? And it will return all the indices in which that is true. But I think stem, what is stem actually? Stem is artificial inanimate. So I think that's returning. So that's returning all instances of 1. Since that's 0, that's the 0 index. 1, 2, 3, 4, 5, 6.
Yep.
6.
Yep.
7, 8, 9, 9. So it returns all those indices. So this allows me to use those as IDs, or like what order do I want to place the actual numbers of trials so that they fit in the order that I want them to. And then once they're arranged, right now I'm just plotting the order of the categories as they are now. So this has it where I have 3, then 2. So it's like the other step-up plot, but now it's reordered in the way that naturally fits.
And the bars connecting are still not meaningful.
Yes, and these ones, the bars connecting, are still not meaningful. And then we can plot it again, except with a more natural ordering. So now we can kind of see a little bit more structure to this graph, right? Does this look a little bit more structured?
Yeah, it does.
So we can see human face and human body part, non-human face, non-human body part, and we can see that like, there's more similarity between the trials for like this human face and human body part for this fusiform face area, which I guess kind of makes sense if we think about the fusiform face area.
How people describe it.
Yeah. So
I would also expect that there would be a lot of activity for non-human faces as well, which it looks like there is, at least similarity.
Yeah, because it's not directly measuring activation per se. It's just looking at the Yep. Similarity. So then they walk through some ways of generating simulated data. So in case you've ever wanted to test, like, I always love seeing examples of people generating simulation data because it's something that I don't have a lot of exemplars to look towards, but it's really nice to be able to create some simulated data so that you can figure out whether or not what you're doing is does what you expect it to do. So I love seeing examples of creating simulated data because it's something that lots of people say that, oh, you should do it, but then no one gives examples of how exactly you do it. So kudos making simulated data. And here they plot it out. In this case, the similarity is just for within the category. I guess how they did it is that the groups are only similar to each other. So there's no, say, like, if this was, I'm just going to call this all one group. Say if this was faces and this was places, then there's no relationship between faces and places for those two groups. And then they also make one in which there is a relationship between two different groups. So if this was faces and places, and what's another word that rhymes? Races? No, that's not. Like running races. Laces? Laces. There we go. So maybe faces and laces are two groups that in this particular simulated neural region, they are correlated with, or they are similar to each other. Mm-hmm. So now with that, this is pretty much what I wanted to cover for this. So there's some exercises that I didn't quite do, and it covers a little bit more, but again, some of it will be an exercise of your for your own edification.
So how is Brainiac doing this per se, and not just you using normal Python script? Or is Brainiac really just showing you how this can be done in Python script?
So Brainiac, right now, I'm kind of a little bit on the fence as well. I mean, Brainiac has some nice utility functions, but a lot of the stuff that they showed here was just plain old, well, not plain old Python, but like scientific Python with NumPy and Seaborn and Pandas.
Yeah, and Scikit.
But I think that what they can help with is also providing some of those helpful utility functions for like doing that digitized thing that I didn't talk about. Which now, looking back on it, if I was trying to advertise Brainiac, I should have focused on that.
The stuff that made it most unique.
Yeah. So let's take a look at Searchlight and see just like what they import here. So Brainiac. So it looks like they have Searchlight function, which is something that I would not want to implement myself, and prepare Searchlight MVPA data.
Time. Is that a clock?
Where does it say that?
Import libraries time. I've never heard of that before.
Import libraries.
It's
time
right above the Searchlight.
Yep. Oh, import time. All right, yeah. With this one, it's
just a clock.
I think that's just supposed to measure like the time, or helps measure the time it takes to run a particular process. That's my intuition. I think that there's supposed to be like a Jupyter Magic that you can run called like %sign time it, and it will like run your code. No, I can't open this one. one's not actually open. Let's see if it works in here. Let's see if Jupyter Magic works. So if Jupyter Magic works, I think I should be able to say that. Nope. Time. Cell Magic. But no, they did Matplotlib up above, right? So, yeah, or is it just one?
They only imported Python.
Time it?
Oh, there you go.
What? That didn't do what I wanted though. It's supposed to show. I guess I haven't actually ever used it, so I don't know. But from what I've seen, time it's supposed to run the function multiple times and then give you a summary of how long it took to run like that code block. So like run it 5 times, it'll give you like a mean and a standard deviation of how many times it took to run that, or like how long it took to run that.
Maybe that's just that for the ROI data, ROID dot shape that it's pulling out for. So maybe that's why it looks the way that it does there. But change if we hit run.
What's up? Wait.
I don't know.
Yeah. I mean, I got rid of the shape, so. All right, well, what if I give it an argument? So it should run that 5 times. Okay, now it gave me the output that I expected. It gave me lots of loops. Okay, that was more than 5. Yeah, best of 3.
Nanoseconds per loop. Nanoseconds, right?
Yeah, nanoseconds. So yeah, in case you're trying to do some benchmarking performance stuff, you could,
That's kind of
you could use
interesting.
that. Yeah.
That's useful. I should tell that to Dylan.
Yeah, is she looking at some benchmarking stuff?
Yeah, well, all this stuff they're interested like with the ECOG and the EEG work. So we're getting really like time and speed.
Yeah.
Very fast. We need to like really get a good gauge of like how.
So in case you want to compare 2 methods to see like which one's faster.
Oh.
Yeah, if it can be run in a Jupyter notebook cell for something that you can really modularize and like, this is what I wanted to, this is the exact function that I want to test in a Jupyter notebook cell. Yeah, you could do some comparisons to get your intuition. But yeah, I think that I guess right now my conception of Brainiac is that it's not necessarily like it's all on its own pipeline type of thing, but as we've been kind of hinting at, it's like utility, like little utility things that you wouldn't want to implement yourself, but it helps you in your like general analysis workflow. So it helps eliminate like some of the boilerplate, or for like more advanced like statistical processes that you are afraid that you didn't code correctly, and that you just want to rely on another package to say, I am going to assume that they wrote this right. So that you will be able to kind of leverage some of the hard thoughts that they put into writing the software. But yeah, but they're not trying to replace like anything like NumPy or Pandas or Seaborn. They're just trying to be like another, as far as I can tell, like another plugin that you can plug in to your analysis. All right. Were there other questions? Excited to get started with Brainiac? You want to start using it?
I'm getting interested in their machine learning stuff. You click on it and then you look at that.
Yeah, so for the tutorials, like some of the machine learning.
Seems to be.
Run a classifier using leave one out cross validation. So I'd be interested to see if I wanted to do this activity flow mapping idea. I want to ask it a question about how much this resting state predicts this task-based performance in an area that I'm leaving out.
Let's see.
Every subject. I sort of made that up. I pulled
Yeah.
it from a publication in my head.
All right. Looks like they don't even import anything from Brainiac in this one.
That's interesting.
Right? Nope. Okay, never mind. They do.
What is utils?
So utils is just like utilities that they developed to help kind of load things.
Do you get to choose how you load these? Is this word labels arbitrary, or is it something that they predefined?
So what's? Could you ask that again? Sorry. So the question.
What do you load labels? Labels that you have from your own data.
Load labels.
So it goes load import load data load
Yeah.
labels label to TR.
Yeah. So I might just say the question again so that so people listening online can hear it. So that load labels, is this something that they've like defined, that they have made for? I mean, as far as I can tell, load labels works for the data set that the tutorial is loading up.
Okay.
So if you make your data look like the tutorial data, then I would assume that the load labels function would work as you would expect. But I'm guessing that the load data and load labels are pretty specialized to the tutorial data sets that they were running. Okay.
Because when I look at the constants that they call it for the VDC data, this is how they're defining it from that whatever. So their ROIs are FFA and PPA, and their labels are 1 equals faces, 2 equals scenes, 3 equals objects, referring to the child type.
Mm-hmm.
Whatever block that it was done, they did 3 blocks, TR 1.5 seconds. They're using an HRF function.
Mm-hmm. HRF flag, yeah. Guess I'm not quite sure. I need to spin up and download this data, and I guess like this was the big one. This was the big data set that looked like it took like 10 minutes to download.
Oh.
So I might not actually run this one right here right now, but
Grid search CV. No, not guaranteed.
Yeah. I mean, I feel like this is another like aside, I guess. Like there is becoming a bit of concern from like people running machine learning models and all this open data that we have. Is that once you apply a model to the data that you've collected and then you share it, then people are not agnostic about like what type of information that data has anymore. Like there's already been an analysis that's ran on it, and then you have information about that data besides the data existing. So like when people try to come from, like, I guess it gets a little bit pedantic about like the statistical assumptions that people make. But once you keep if you like keep hammering different statistical analyses on a data set, like it's just for machine learning, it's just like another form of p-hacking almost.
I feel like this came up with McCall's talk last year, where somebody was like, she was having issues with she was doing something with machine learning, and she had issues with something, and somebody in the audience was like, well, have you trained it to the alternative that you would also expect to happen in some of the cases for the areas you're looking at? And she was like, no. She goes, you might be biasing your algorithm. Is this sort of the idea you're getting at?
That might be slightly different, because this one doesn't necessarily deal with like I might need to get more context on the situation.
The one I'm talking about, McCall?
Yeah, the one in the situation with her. Okay. To know exactly. Yeah.
I don't remember that.
I do not. But yeah, I think this was everything about Brainiac that I wanted to cover. And then I guess since it's just us two, I know that Adriana can't make it to the Brain Hack, and that you're going to.
Are you
on the committee?
Either?
Oh. No, he's gonna make it.
Oh.
You're the only one. I said no. It's fine. No, you got your.
Remind me. So the date for the actual Brain Hack's the 27th.
It's the 23rd and 24th.
Okay, perfect.
Mm-hmm.
Yeah, that's so good. We're good.
My comps is the 25th.
Yeah.
I moved that week.
To where?
I'm just moving apartments.
Okay. I guess we should probably stop the recording now.
Yeah.
Thanks for listening.
Thanks, guys.